Okay, welcome back. So we've talked recently about lists, we've talked about dictionaries. There are other collection types in Python, and I think it's worth sort of going over and looking at them. I first want to start with looking back at our dictionary. So this is our work on dictionaries, and we talked about this is how you declare a dictionary, this is how you make changes in a dictionary, and here's how we delete information and then loop through a dictionary. Let's stay in the same file, but let's look at a different data type. This data type is called a tuple. You might also hear it referred to as a tuple. Both pronunciations are fine. You'll hear me say tuple, tuple probably interchangeably. So let's talk about how we declare one. First of all, we do so in a similar way as lists, except in this case, instead of using square brackets we did for a list, we're actually going to use parentheses. And a tuple can have different data types inside of it. It doesn't really matter. It's fine. It can contain a long list of information. It can contain one piece of information. The key difference between a list and a tuple is that a list is mutable, meaning we can change it. Mutable means changeable. A tuple is not. So, for instance, let's say I wanted to get information out of our tuple. We would actually reference that information in the same way you would reference information out of a list. So if I go ahead and clear down here, and I run our dictionaries here, you'll see that first thing printed out of our tuple is hello. Let me go ahead and comment, or we can just remove that for now. And you'll see, let me do that again for you, and you'll see the only thing printed out of our tuple is hello. We can also index it using 1. And you'll see the second value in our tuple is 5. So it references very much like you would reference a list. You don't always have to use parentheses. It is very common to use parentheses, but we actually can do this without parentheses. And then if we were to reference our second tuple, and we were to reference the third value of that second tuple, we're going to get false. Okay, so referencing a value of a tuple looks exactly like you were referencing a list. Now here's the key difference. If I were to say I wanted to change a value in our tuple, let's say I wanted to change the fourth value, or the third value to true, and I run this program, I'm going to get an error because tuples don't support that kind of assignment. You cannot change a tuple. It's immutable, its values. Even if we wanted to add a value, we're still going to run into trouble. Right? That's adding a value. There is no fourth value in our tuple yet, but even trying to add a value doesn't work. So tuples are immutable. They're basically become constants, and you can't change them. So tuples, just to remind you, are like lists, except we're going to declare them using parentheses typically, but we don't technically need the parentheses. We can index them, we can loop over them, we can iterate over them, but we can't change them. Okay, so that's the important thing to know about tuples. Tuples also don't have to be unique values, right? I can have false again, I can have 6 again. None of that is going to be a problem in our code, and I'll run it just to show you. That's all fine, right? We don't have to have unique element values. This differs from the next type of collection I want to show you, which is a set. A set is actually more closely linked to a dictionary, but without values, just keys. And everything has to be unique within a set, and technically it's unordered. So, for instance, if we wanted to declare set 1, you can build a set off of a list. So you would use the keyword set and open your parentheses, and then go ahead and put a list inside. Something like this. And then we could say print set 1. I'm just going to comment out that print statement. Nope, not that one. I'm going to comment out this print statement up here so that we don't get confused. And we can see what it looks like when it prints out our set. And you'll see it's 1, 2, 3, 4. You can also just use curly braces to declare a set. Kind of like we're doing a dictionary, but without keys. So, hello. Goodbye. Sam. Both in these cases are sets. So you did hear me say that they have to be unique values. So if I were to try to do, let's say, up here on set 1, if I were to add 5, 5, 5 to our set, watch what happens when I print out that set. So theoretically, our set should have 1, 2, 3, 4, 5, 6, 7 elements, 3 of which are 5. But when I print it out, I'm actually only going to get 1, 2, 3, 4, 5. One of the unique things about a set is that each element has to be unique. So when you pass data to a set, it's automatically just going to truncate away any repeat data and just limit itself to what data is unique. And it doesn't even throw an error. It just does that. And it's actually really useful for solving some problems. If I gave you a whole set of numbers and I said to you, just tell me the unique integers in this data, you could quickly convert it to a set and print out those unique integers without too much trouble. The same thing works for strings. If I tried to put the exact same string twice and run it, I'm going to run into, it's going to carve off that last Sam, and it's just going to print goodbye, hello, Sam. Unlike tuples, sets are mutable, so we can make changes here. So for instance, if I wanted to do set 1 dot add, I could add a value to set 1. Let's say I wanted to, or I can even add multiple values, I think, if I wanted to. But let's say I wanted to add a 6 to set 1. Print set 1. Let's go ahead and change this statement up here to print set 1, and we can see the change. And there you see 6 has been added. Let's take away our repeat 5s. Let's go ahead and try to add 5 to our set. Remembering 5 is already in our set. Let's see what happens when we try to add 5. Nothing. Because it's not a unique value, we don't throw an error, we don't have an issue, we just say, nope, sorry. Not even nope, sorry. We just say, yep, we've added it to our set, even though it's already represented in our set. Which is valuable too, because if we're trying to make a list of unique things, let's say you're making a shopping list and you add milk and you add eggs and you add cheese and you're adding this big list, and then your user adds another milk again, unless you want to sort of keep track of how many they've added of each one, you can kind of say, okay, yeah, milk's on the list, no worries, right? Without throwing an error or anything. Let's say we want to take something out of our list. We can use this remove method, and we'll go ahead and remove 4 from our list, and there you'll see it gets, or from our set, and there you'll see it gets removed from our set. What if we try to remove something that's not in our set? Let's say we try to remove 6. We are going to get an error in this case. So much like our delete from our dictionary, and I told you there's sort of a relationship between sets and dictionaries, you want to use a try except block when you're doing this kind of removal. Oh my goodness, can't spell except. Okay. Print element not in set. Right. That takes out the error and just tells our user that element's actually not in the set. So don't worry about removing it. So that, again, I think shows you that sets, unlike tuples, are mutable. And like dictionary keys, have to be unique. Because dictionary keys have to be unique. Set elements have to be unique and won't be repeated. One other collection type I want to show you, very obviously closely related to sets, are what are called Frozensets. The big difference here is a Frozen set is a immutable, so not mutable, version of the set. So let's go ahead and make one for ourselves. We'll say Frozenset equals, we use the keyword Frozenset, and then we pass it a list much like we did with our set. So all the same rules apply. Right, all the same rules apply. You'll notice this time, though, when we print out our frozen set, it does tell us that it is a frozen set, except that now we don't have any methods for like adding or removing, because frozen sets are immutable. They're not going to change. So they're like sets, but they're not going to change. But then all the other rules apply. So for instance, you're not going to have, if I tried to write 4 for 4 here, and then did the same thing, you're going to notice that the frozen set just trims off those 4s, and we're just left with 1, 2, 3, 4. So all the values are unique, but this is not this is not going to be mutable. In terms of iterable, so for item in set 1, print item. Let's do for item in F set, print item. Remember, item is not like a keyword or anything. It's just the word I'm using in these two cases. But let's go ahead and see what happens. You'll notice in both cases, it is iterable. It loops over the set. It loops over the frozen set. No problem printing out each element. These are not indexable. We can't go in and say, I want the 0th element of a frozen set or a set. For instance, let me show you. If I try to add here a 0 at the end, I'm going to run into an error, and it's going to say not subscriptable, which is the same thing. It's not indexable. We can't go in by index to get an item out of the frozen set, but we can iterate over them. We can loop over them. So I've shown you lots of sets. Let me jump back real quickly and just show you, I think, what is a helpful table to label everything out so you have an idea of what we're talking about. Lists are ordered. They are iterable. They do not have unique elements, so they can have repeatable elements, and they are mutable. Very flexible lists are. In terms of iterable, because they don't have like a key value pairing, if you're sort of searching for something, it can take a little bit longer, but generally a really flexible, easy data collection to use. Dictionaries are not technically ordered, although they will, since Python 3.7 maintain the order things are entered in. Oops. Let's go back. They are iterable. We showed that, right? We have a couple of different ways. We can loop over all the keys. We can loop over all the values, and that's what iterable means, right? Can we loop over these things? And we can loop over the items, meaning the keys and values as a pairing. And if you remember when we talked about that, when we do loop over a dictionary's items, the items values are being returned as a tuple, right? A key value pairing. Keys do have to be unique. They are not mutable. Values don't have to be unique, but are mutable. Okay, so that's the difference there. Keys are unique, not mutable. Values are not unique and mutable. In a tuple, they are ordered, right? The first value is the first value, the second value is the second value, and they're indexable, right? They are iterable. We can loop over them. The elements inside do not have to be unique, but they are not mutable. So they are probably closely related to a list, most closely related to a list, with the key difference being they're not mutable. Okay. A set is not technically ordered, meaning we're not going to index anything in it, but it is iterable. The elements do have to be unique, so that's what sort of makes sets unique from all the other collection types. The elements inside will be unique, and in a set, it's technically mutable. However, if we don't want a mutable set, if for some reason we want our set to be constant once it's been declared and initialized, then we go to a frozen set, which has all the same properties. It's not going to be indexable. It is going to be iterable. The elements are going to be unique. However, it's not mutable, and that's a key difference there. So here, hopefully you can kind of see all the different Python collection types, or at least the ones we've talked about in this course, and the key differences between them. And I hope that starts your gears turning. And when you're thinking about building something, what kind of collection type is going to be most useful for your specific use case? And you're going to have to play around a little bit and see what's what. But this is all of the collection types we've talked about in one place.